Alright, so how's everybody doing? Cool. Pass around a sign-in sheet for today. And if you have your information sheets, if you didn't turn those in yet, drop those off when you get a chance. If you need an information sheet still, I brought in a few blank ones so you can come up after class and get one of those. So questions so far? So I want to finish going through Git. I want to look at GitLab online and talk about how to connect GitLab to your own private Git repository, and then I'll talk about homework 1, which is fairly self-explanatory if you understand Git, but we'll look at homework 1, and then I want to talk about bash scripts and start working on how to make a script, how to make it executable, and put some commands in it. Then we'll look at ODP 402, which is going to require you to write a short shell script. And then I'll, if we have a few minutes left, I'll talk about this VI weirdness. What happens if your VI session goes away and when you edit your file you get that message saying swap file located, you want to abort, overwrite, load, blah blah blah. It happens eventually to everybody, so we'll talk about that and how to deal with that. So let's start with Git. So let's hop over to Goblin King, and let's make a Git work directory, and we'll say git init. And let's add these things to the repository, and let's commit them. I wiped out my Git setup so I could do this from scratch. So if you don't set up your VI editor, this is what comes up. It's Nano. It's a more intuitive editor than VI. Using VI will help you play Rogue. All right, so I have a Git repository on my local machine. I've got two files checked in. Let's hop over to GitLab. So gitlab.com, and you have to set up an account, and mine logs me out all of the time. So I've got projects out here, but the first time you do this, you won't have any projects, and it'll give you a welcome message and stuff. So what you need to do is you need to set up the secret handshake between whatever machine you're running Git on. You're usually running Git on the Linux server, linuxengrcs.com. You can be doing it on your own laptop, you can be doing it on your phone, your Raspberry Pi, whatever. But whatever machine you're running Git on, in this case right here, you need to set up the secret handshake so that GitLab and your machine understand one another. So I updated the how-to, by the way, and it's got information on how to do the GitLab setup. So main thing you need to do, you need to generate a public-private key, okay? If you're in CSE 215, we'll spend a unit talking about cryptography. We'll talk about public-private keys and how this kind of handshake works. But basically, the command is given to you, SSH keygen, T says type RSA, that's the type of encryption that's being used, block size of 4096, -C, and then you put in your email address, the one that you used when you set up your GitLab account. And so ssh-keygen -t rsa-b 4096-c, and I'm going to use my email address. That should be -t rsa, not r. Alright, so generating public-private key pair, enter file in which to save the key, take the default. Okay, this is where you want it to go. I've already got one in there. This won't happen when you do it. So yeah, overwrite the existing key. Let me... Alright, so generating public-private key pair, enter the file in which to save, take the default. It'll say enter a passphrase. I use an empty passphrase. If you put in a passphrase, it's an extra thing you do have to type in every time that you try to push things over and stuff. So I'm just going to use an empty passphrase, enter the same passphrase again, press enter. It gives you some nice little picture of what your public key is, and doesn't seem to do anything. Okay, what it's done is it's created a set of files in a hidden directory. So go into your home directory, and you'll see a file, a directory called .ssh. And if you go into there, there's a pair of files, IDRSA and IDRSA pub. That's a pair of strings, big long strings. And if you, I don't want to get into how cryptography works, but if you know the private one and somebody else knows the public one, you can authenticate that you are each who you say you are. And so let's take a look at this .pub file. This is a big long string that uniquely goes with my private string, which is in IDRSA, which I'm not going to show you, because if you show it to you, you can be me. So the idea is we're going to take this big long string, we're going to provide this to GitLab, and we're going to keep the private string, which is in this IDRSA file, secret. Okay. Now when I try to push something over to GitLab, GitLab will basically check to see if I know the secret password. And it can verify that using this without figuring out what the secret password is. So we got to push this over to GitLab. So I'm going to copy this, which I can do just by highlighting it. Alright, so now you got to go over to your picture, go over to settings, come down to SSH keys, and in here you just want to paste the key. And when you paste it, you got to be careful. You need it to paste as a single string. You don't want a break at the end of each line. So depending on how your system is set up, there may be different ways to do that. And then you're going to say add key. And if I try to do that, it's going to tell me the key's already there because I've got a bunch of keys, including Goblin King. But say add key, and then you're set to go. That's all you need. All right. So Linux machine, do your keygen. Copy the file from .ssh/idrsa.pub. Paste it into GitLab under SSH keys. Say add key, and you should be set up. It should know who you are every time that you try to do something. All right, so let's push something over to GitLab. So I'm in my Git work directory. And on how to, it says adding your project to GitLab. Okay, so when you're ready to push your project to GitLab, make sure you're in your project directory and then do the following. And it's one line. Yeah?
Do you need a different SSH key for each machine or device?
Each machine that you're on, yeah. So Linux server, your own laptop, your desktop, that would be 3 keys. Alright, so one line, git remote add origin, git at gitlab.com, your username on GitLab / what you want to call the repository on GitLab, and then it's got to end with .git. So I'm in a Git work directory. I'm just going to call my repository, I don't know, I'll call it 224 git or something like that. So git remote add origin git at gitlab.com colon Nick Macias slash 224 git work dot git. Alright, so what I've done is I've set up an association between my repository on my laptop and this repo over at gitlab.com. And anytime I want to synchronize things up, anytime I want to push my current repo over to GitLab, git push origin master. Okay, this remote add origin, that's a one-time setup per project. Once I've done that, there's an association set up here. So now I want to push my stuff over, git push origin master without any typos. And the first time you do this, it's going to ask you if you want to trust, because the first time you set up the secret handshake, they haven't talked to each other yet, and so you don't actually know 100% if this is really who you think you're talking to or not. Right? It's the person in the middle attack problem. So first time you do it, yeah, just go ahead and say yes. And I knew something would happen. Oh, because I didn't actually add the key. All right. Let's go ahead and actually add the key. All right. So let's try pushing again. All right, and we're done. I thought I already had a key on there. So that's it. So if we go to GitLab and we look at projects and we go down to your projects, there's a 224 git work repository. And I can click on that, and it's got two files, a readme and a main.c. And the readme says haha, and so on and so forth. Okay, so that's the setup. How does this work on a day-to-day basis, right? So let's edit readme. Alright, so there's my actual readme for this. So how do I push this into my repository? What are the two commands I use? Git add readme, and then git commit. All right, and then how do I push it over to GitLab? Git push origin master. And we're done. And if I come back to GitLab now or some other point, and I were to click on my project, 224 git work, oh, it's already there. So there's the README, right? And that's the new version of it. And if I want, I can click on history, and I can see here's the initial check-in that I did, right? And I can see the version of README from back then, and I can download these, and I can compare them, and I can do all kinds of things. So basically, you make a bunch of changes to your code, git add, git commit, git push, and bang, everything's like pushed over to the server. And we're going to talk about how to make shell scripts in a few minutes. You can put all that into a shell script called, go. And then you just say go, and it adds everything, it commits it, and it pushes it over to the server. And now as you're working and you're making changes, anytime you're feeling like you're at a good place, just say go, and poof, everything gets synced up to the server. It's there. If our Linux server goes away, you can still get your work back. If you're not able to get to the Linux server and you want to run on a different machine, you can pull stuff down. So it takes a little bit of setup, right? But once you've got it in place, it really just kind of like stays out of your way. and it's there. And if you never have to use it, that's fine. But if you ever need it, you'll be really glad that you've got stuff on Git. All right, so questions about that? I know I went through that pretty fast, but it's all in the how-to, and it's recorded on the video. And a number of people have gone through this on their own already. So let's talk about homework 1, which you've basically just seen me do. So homework 1, go ahead and get yourself an account on GitLab, set things up, set your configurations, and put in your secret key and all that kind of stuff. And then make yourself a repository called HW1. Okay, and it's got to be exactly uppercase H, uppercase W, number 1. Oh, the thing I didn't show you. Add me as a reporter. So you're inside your project. Okay, for you this would be homework 1. Go down to settings and members and invite a member. And so put in my membership name, which will be Nick Macias, okay, and it's in the instructions, uppercase N, uppercase M, and then choose a role, set me up as a reporter. Reporter means that I can look at what you've got in your repository, but I can't make changes to it. And Nick Macias, and then just say add to project. And that will give me access to look at your repositories, to pull them down to my machine, and then look at the work that you've done. So your programming assignments, you know, develop them on the Linux server or on your own machine, push them up to GitLab, and then at some point you need to go into GitLab and you need to add me as a reporter on that project so that I can download it. Alright, so add me as a reporter, and then I'd like your repository to include 2 files, a readme.md file, so just make a file called readme.md. And just tell me who you are, what experience you have with Git. It's just something to have in there. And then also take whatever your source code was from ODP 401, your main.c or whatever you called it, and push that in your repository. So your repository should have 2 files in it, readme.md and then something.c. And then go on to Canvas and submit your assignment. And if you're doing this as a student, there'll be a submit button. And your submission will take 1 line of text, which is your Git username. Okay, not your Clark username or your Linux server username, but the username you gave to Git. Okay, and then you're done with homework 1. And then Friday, after this closes, I'll pull down all of your repos onto my local machine, and that'll confirm that you've got this push process, and I can pull things down, and you'll be all set for programming assignment 1. Does that make sense? So questions on what you're doing for homework 1? So you need this by Friday morning at 8 a.m. So if you haven't done this already, go through those steps, and if it's not done by tomorrow morning, ask questions in class tomorrow, or catch me in my office hours tomorrow, and we can go through it. All right, let's talk about shell scripting. So basic idea of a shell script, we said the other day, is basically you can take a set of Unix commands and you can put them in a file, and by typing the name of that file, it will execute those commands one after another after another. So so let's use Git as an example. Suppose we want to be able to do a git add star and a git commit, right, repeatedly. So add things to the repository. Git commit is weird because it always pops up this editor window, right? So on git commit, you can use a -m switch and specify a message after that. And it saves it from popping up an editor window that you have to type into. But you know, my message is just checking in. It doesn't really say anything. But if you just want to make a backup checkpoint along the way, right, you can just do a git commit -m check-in. So I want to do these two commands a lot, right? Every few minutes I get nervous about my editing, so I want to push everything into my repository. So let's make a script that executes these two commands for us. So I'm just going to make a file called save, and I'm going to say git add star git commit -m, just checking things in. So I make some changes to my README, and I'd like to execute these two commands. Okay, I've got these two commands in a file called save. Theoretically, all I have to do is type the name of that file, and it should execute these. There's a few details we have to take care of. If I try to say save, it will tell me permission denied. So there's this notion of every file has a set of permission bits saying what can be done with this file. In particular, who can read it, who can write it, and who can execute it. And if I do an ls-l, this first row of this first set of characters, these are the permission bits. And the first 3 bits say what I can do, the next 3 say what people in my group can do, like other teachers, and the last 3 say what anybody on the system can do, what's called world. So I have permission to read this and to write this. I do not have permission to execute it. And nobody else has permission to do anything with this. If you try to look at the contents of this file, it'll say permission denied. Okay, so I need to give myself permission to execute. And the way we do that is chmod 755 in the name of the program. And we'll talk more about chmod later. It does a lot of stuff. But what this is actually doing is it's changing the permission so that everybody has permission to read and execute this file. And I've also got permission to write it. Right? So owner, that's me. I can do read, write, and execute. People in my group can read and execute, and everybody else can read and execute. And 755 is a code for this particular set of permissions. And we'll break down that code another day. But for first purposes, if you want to be able to execute a file, just change mode 755 and the name of the file. And now if I say save, it goes ahead and it executes the commands inside that file. So it added my changes to the repo and it did the commit. Still with me? And you can put anything you want in here, right? I can say, let's see what the date is, and let's see what my working directory is. And let's echo a message to the screen that says, hello, Nick. And now if I say save, it shows me the date, it shows my working directory, it says, hello, Nick, it does a git add and a git commit.
So this is only going to be in this directory, so if I wanted to do this often, I would have to keep writing.
Yes, so this is only in this directory because if I'm sitting up here and I say save, it doesn't find that command. Why? Because there's nothing in this directory called save. But if I'm under this work directory, there is a command called save, and so it knows how to do that.
Would using alias be like more of a local for you to run that?
Yeah, so if I'm sitting in this directory, what I could do is I could say slash home slash nick slash 224 slash git slash work slash save. And there I'm specifying the full path to this file, right? I'm not assuming that save is in my current directory. I'm saying it's in the collection of home directories under username Nick, under 224, under work, under save. And you can set up an alias to be equal to this long string here. There's other ways we can do this too. I got error messages here because I'm not sitting in a Git repository. I'm just in my 224 directory. But if I go in the work directory, then that'll work just fine. Alright, there's one other detail that we need to use, and this will look optional for a while, but it's actually pretty important. This file save is just a set of commands that say show me the date, print the working directory, etc., etc. And chances are any shell that I'm using, if I type the word date, it's going to print out the date. If I say pwd, it's going to show me what my working directory is, right? But when we start getting into more programming, we start doing if statements and loops and things like that, the syntax will vary from one environment to another. So we're using a shell called bash. Some people use a shell called C shell, CSH. And the syntax for an if statement in C shell is totally different from the syntax in bash. And if somebody is sitting inside C shell and they say save, and there's an if statement that's meant for bash, they're going to get a syntax error. So since we're working in bash, what we want to do is make sure that no matter what shell we're actually using, this gets executed by the bash shell. And all of that is just motivation for saying the first line of your script needs to be what's called a shebang. It's a number sign followed by an exclamation mark, followed by the path, the full directory location of the shell you want to use, which for us is going to be /bin/bash. So this has always got to be the first line of your shell script.
We're having spaces in between the bin and bash and all that stuff.
That'll break it, yeah. So what is the number sign? It's a comment. Right? Any line that begins with a number sign, it ignores whatever else is on that line. So this will not remove all my files. But if the first line of your script starts with a number sign followed by an exclamation mark, the shell interprets that differently. As more than just a comment, it says, oh, they want to run this through bash, and so it will start a bash process and feed all of this stuff to it. It's kind of a trick. And if it doesn't make sense what that's doing or why it's doing it, don't worry about that for now. Just make it a habit. When you write a shell script, first line should be number sign exclamation mark /bin/bash on this system. I can look at my Git log, and I've got several versions of my repository already. I can't tell what's what because they all use the same message, which is just checking things in. But every time that I make a change to this script save, when I run save, it's checking in a new version of it. Right? So this latest version is the one that has the shebang at the top. But I don't have helpful messages in here. That's okay. Alright, so you want to write a shell script, put the shebang at the top, put in all the lines of code that you want to execute, and then one time do that change mode. And you only had to do that once, right? I did that a few minutes ago, and the permissions on this file are still 755. They're still executable. If I make a new file, and I try to run that, I get permission denied. Because every time you create a file, it starts off by default not being executable. Right? Save to is just read write, so change the permissions on that once. Save to, now it's executable. Make sense? Alright, so we're going to spend a lot of time doing more than just putting commands into a shell script. right? That's a useful shortcut, but like I say, there's a whole programming environment inside Bash. We can do loops, conditionals, we can do input and output, and we can do any Unix commands that we want. So it's a really rich programming environment. But for ODP 402, all you got to do is be able to put a few commands into a shell script and assess it. So let's look at ODP 402. So similar to ODP 401, but you must write a shell script instead of a C program, and it should print out a picture of a cow saying hello world. Alright, so how do we print an image of a cow? Well, there's the most useful command in Unix, which is cowsay. If you say cowsay followed by anything, you get a picture of a cow saying whatever that string was. So cowsay hello world. There's the output that you want your script to produce.
Really putting the important stuff in.
Yeah, this is the important stuff. And we talked about pipes the other day briefly, right? The idea you can take the output of one command and feed it to the input of another command. So if you just say cowsay without putting anything after it, it waits for you to type in some stuff. This is my input. Hello, bye. And that's what the cow says. So if I were to say something like date and pipe that into cowsay, I get a cow telling me what the date is.
If you cowsay, cowsay.
That gets weird. But thank you for thinking of that. Or you can pipe it into LOLcat and you get the rainbow cow. LOLcat lets you look at a file in rainbow colors. So somebody asked me to add that, so I added that. Alright, so what do we have to do for ODP 402? Make a script that basically says cowsay hello world. So let's do that. So I'll just call the script cow. Put the shebang at the top. Cowsay, and you don't really need it for this particular command. I could just say cowsay hello world, but since I'm trying to print something that has a space in between, I'm going to put it in quotation marks, and we'll play more with that later when we start doing some more programming. But the quotation marks make it clear that like this thing hello space world is what I want to feed to cowsay, and that should really do it. That should be my whole program. So if I try to run it, I get a permission denied. So change it to 755. It's called cow. Alright, so now if I say cow, there's my output. Alright, so let's see if I can get 10 out of 10 on the assessment. Assess cow. Well, it's still going to want the source file as a second name. So you have to assess cow, or main, or script, or whatever it is that you're called your script. And it's kind of silly, but that's what it needs. All right, so double check you're about to assess your code for ODP 402. Show a cow saying hello world. That's the script that I just wrote. Let's go ahead and assess it. Let's use the G command. And 10 out of 10. I'm done. Just exit out of that. Alright, so there's your code for ODP 402. But again, you got to put it into a script, you got to change the permission, you got to be able to assess it correctly. Now let's say I forgot to change the permissions. So when I say cow, I get this permission denied. But suppose I didn't notice that and I just go ahead and assess it. I'll go ahead and grade it. I got a bunch of error messages, but ultimately I got 0 out of 10. Right? This is not the point where you send an email saying what's wrong with my code. Okay? This is the point where you remember the fundamental guiding principle of the assess command, which is assess is not a debugging tool. Okay? So this is one of those really important points that you want to put in your notes and highlight. Assess is not a debugging tool. Okay, if you assess your program and you don't get 10 out of 10, there's nothing that's going to give you any help in debugging there. What you want to do is you want to pretend that this is not a one-day program that you can submit 100 times until you get a good grade on. You want to look at the assignment and you want to think about it and you want to write your code, but pretend that you're going to actually turn this in and that's it. Once you turn it in, you get graded whatever the grade is, that's it. Okay? And what you need to do is test the program yourself. Now for ODP 402, it's a pretty straightforward test. Type in the name of the script and oh dang, it doesn't work. Why is that? Go back to your notes, figure out, oh yeah, I need to change the permission, which I should just alias that, and then run it. Okay, it looks like it works. Now I'm going to go ahead and try and assess it. And if it doesn't give me 10 out of 10 at this point, I don't know what the problem is, right? Go back, was it supposed to be an uppercase W? Was there supposed to be a space in between? And it's always possible that something weird is going on. But chances are your code is not doing exactly what it's supposed to be doing according to the assignment. So as the ODPs get more involved and have more details about what they're supposed to be doing, it's going to be really important that before you try to assess, you make sure you test your code thoroughly. Okay, so an upcoming ODP, it'll ask you to type in a number and print out what that number is multiplied by 2. And yeah, you can write a script to do that, and you type in 10 and it prints out 20 and you think you're done. Well, what if you type in something that's not a number? What's going to happen? Is it going to break or is it going to do something else? What's the assignment say you're supposed to do? What if you type in a negative number? Is that supposed to work or is it supposed to do something different? What if you don't type in anything and you just hit enter? What's supposed to happen then? So a lot of the exercise of these ODPs is about debugging. It's about coming up with test cases and exercising your code and trying to make absolutely sure that according to whatever the assignment says, this code is perfect. And then when you think you've got it perfect, go ahead and assess. Now, I don't mind if you assess a million times along the way. I'm not going to stop you from doing that. But, you know, even if you assess and you get 10 out of 10, your code may not be 100% correct, because I don't test every possible contingency. But more often, you think your code's correct and you don't get 10 out of 10. So does that make sense? Right? Treat the debugging and the testing and the validation of your code as part of the assignment, not as something that you just do if you're not getting 10 out of 10. Okay, because the programming assignments, you don't have this feature. You basically turn it in, and then once the assignment closes, it gets graded. So you want to get into practice of test cases and stuff. Now, one thing I will say you can talk about on Discord is test cases. Okay, if you're writing your ODP and you think it works and you're not getting 10 out of 10, you're encouraged to start a discussion saying, hey, I checked my number, you know, my program, I put in a positive number, I put in a negative number, I put in 0, and I'm still not getting 10 out of 10. Anybody got any other test cases? And somebody might say, yeah, did you try putting in a number with a decimal point in it, like 2.5, and go off and try that, all right? So you can talk about how you're testing your code, how you're analyzing it, and so on. Just don't post code samples, okay? All right, one other piece of weirdness that I'll try to head off, and I don't know if I can make this fail right now, but I'm assessing my script, and something comes along and I decide to go off and do something else, and I come back later and I find that my my terminal session has exited. Right, because sometimes we get disconnected from things, our network connection goes south. I don't know where I put my cow script. I can't make it fail. Okay, well, sometimes you'll be working and you go away and you come back, your network connection has died. And when you try to assess, you'll start getting weird messages. You'll get messages about out of memory or out of resources or things like that. I can't make it happen. All right, I won't go into it. If you get weird messages other than, you know, you got 0 out of 10 or something like that, pop a note on Discord and we'll find a particular case where this happens. Basically, weird things can happen when your connection gets cut off if you're in the middle of running an assess command. You may actually still be halfway through an assess session, and if you try to start a second one, you get weird results. And the punchline is it just won't let you run the second assess. But I'll tell you how to deal with that if and when it happens. But along the same lines, let's talk about the VI weirdness. So I'm editing my cow file. I don't know if I can make this break or not. I'm editing my cow file, and something happens. So my session goes away. So I come back from lunch and I log in and I try to edit my file. Alright, close your eyes. Alright, well, weird things happen. I try to edit my cow file and get this message. Okay, so you've seen this before? Right, it probably popped up in 121. This is what happens sometimes if you're in the middle of an editing session and your connection goes away. Okay, what's happening is when you start editing a file, there's a file created, a hidden file, to say, hey, this person is editing the file named cow. So that if you come in and somebody else tries to edit that same file, it'll say, nope, somebody else is already editing this. The result of that mechanism, though, is that if you're editing a file and your connection disappears, you log back in, you try to edit the file again, it thinks somebody is already editing it. Okay, so this is saying it found a file named cow.swap owned by Nick. Another program may be editing the same file, or an edit session for this file crashed. That's what happened in this case. I killed it, actually. Okay, so what do you do when this pops up? You can just live with this for the rest of eternity, but that's no fun. So here's my suggestion. First thing you want to do, quit. Quit. It's just an uppercase Q. Okay, make a copy of the current file. So if you don't remember, CP is the copy command. Copy cow, cow.save. I'm going to do that before I do anything else, because VI will try to recover the changes that you made to your file and stuff, but I don't want to trust my current file to this weird recovery process. So get out of VI with the uppercase Q command and make a copy of your file. Cow.save, I'm not going to touch that. But if something happens and the file cow gets corrupted, I've got a current version of it right here. Okay, now go back into VI, there's the annoying message. And you have a few choices. So probably what you want to do is say recover. It's an uppercase R. So do an R, and it tells me recovery completed, buffer content equals file. You may want to delete the swap file now. And this should be the version of the file at the point where I walked away and my session died. Okay. If it is, go ahead and save it. If it's not, just go ahead and quit and go back to your cow.save file that you made. Okay, exit and go ahead and edit again, and it will tell you, hey, there's a swap file in there, right? At this point, you can say delete it. So hit an uppercase D, and then quit out, and now if you try to VI, you don't get the annoying message anymore. So you get the weird swap file message, use an uppercase Q to quit, make a backup from the Linux command line, Go back in, say recover, make sure the file looks good, and if it does, then go back in and say delete. And then you're back to where you were. Alright, that's the VI weirdness. So questions on any of that? That was a lot of seemingly randomly disconnected tidbits. But that gets you everything you need to do homework 1, due Friday, ODP 402, due tomorrow morning at 8, and deal with weird disconnects. Which means we're all set for tomorrow to talk about programming in the bash shell. So the echo statement for doing output, read for doing input, setting up variables, doing arithmetic expressions on variables, which will set us up for ODP 403. And then we can talk about looping, which gets us set up for ODP 404. And then on Friday, we're going to talk about programming assignment 1, and we're going to talk about the service learning project. Okay, we're also going to have someone from Student Support Services come in Friday to talk to the class for 5 or 10 minutes and talk about various services that Clark makes available to students. Just so that everybody is familiar with that. You should have seen it your first year here, but I want to make sure people know what resources are available. So that's our plan for the rest of the week. I will see you tomorrow or in 2:15.